Welcome to Balaya Math Lectures. Learn every step. Now coming to the definition of idempotent matrix. When will you say that a matrix is idempotent? If suppose A is a square matrix, if A square is equal to A, then you say that it is an idempotent matrix. If A square is equal to A, then A is an idempotent matrix. We have the positive integer m such that a power m is equal to 0, then you say that a is nilpotent. If a power m is equal to 0 for some positive integer m, then we say that A is nilpotent. Let us learn minors and cofactors of a square matrix. A minor can be calculated for an element of a square matrix. Suppose if you have a matrix B, some A11, A12 up to A1n, A21, A22, so on, A2n, AN1, AN2, so on, ANn. That means this is n-row square matrix. Now, if you wish to find the minor of this element, you have to exclude this row and column, and you can find the determinant of the rest of the matrix. That means from A22, A23 up to A2n, AN2, AN3, so on up to ANn. If you find the determinant of this one, then you can say that this is the minor of the element A11 of the matrix B, and it can be usually represented as Mij. And in fact, you are finding for the first element, you can say that this is M11. Your M11 is the minor of the element A11. Now, coming to the definition of cofactor of a matrix. Simply, you can say that the signed minor means minus 1 to the power of I plus j into the determinant of Mij. If suppose this is matrix Mij, and you can find the determinant of Mij. I means row, j means column. That means that element is in which place? That means is it in the first row and first column? Then you can put the value of I as 1 and j as 1, and your minor is also m11. That means minus 1 to the power of 1 plus 1, 2, minus 1 whole square, which is 1 into the minor m11 is your cofactor of the element A11. Similarly, you can find the cofactors of remaining elements also. That means if you wish to find the cofactor of A12, then this will be minus 1 to the power of 1 plus 2. This is in a first row and second column. So ith value is 1 and jth value will be 2. So minus 1 to the power of 1 plus 2 into the determinant of M12. M12 means you will be exclude the first row and second column, but not first column. First column will be as it is. That means your minor will be A21. You will remove this A22, A23, so on, A2n. Similarly, you will remove this AN2. That means AN1 up to, so on, AN1, AN3, so on, ANn. The minor of this one. So you can get the cofactor of the element A12 of the matrix B. This is generalized case, but you need to understood by taking an example. Let me take a small example here. Suppose your matrix namely C is equal to matrix 1, 2, 1, 2, 1, minus 2, 1, 2, 3. Now I would like to find what is the cofactor of the element 1. Cofactor means my cofactor of 1. Cofactor of 1 is equal to, this 1 is in first row and first column. So minus 1 to the power of 1 plus 1 into determinant of, you have to remove this column and this row. What will be remain? 1 minus 2, 2, 3. 1 minus 2, 2, 3. And the determinant of this will be 3 plus 4. 3 plus 4, 7. So minus 1 to the power of 2 is minus 1 whole square, which is 1. So your answer is 7. AD minus BC, which is 3 plus 4, which is 7. So the cofactor of 1 is 7. Similarly, cofactor of 2, you can find cofactor of 2. How can you find the cofactor of 2? That means you have to exclude the first row and second column. The rest of the matrix will be 2, minus 2, 1, 3. That means minus 1 to the power of 1 plus 2 into 2 minus 2, 1, 3. So minus 1 whole cube means minus 2 3s are 6. Minus 2 minus plus 2. 6 plus 2, 8. Minus 8. Minus 8 is the cofactor of 2. So I think you may got how can you find cofactor of an element of a matrix. And also you can find the minor of an element. So determinant is defined for a square matrix, minor is defined for an element, and the cofactor is also defined for an element. I think you got the difference between all these definitions. Now let me discuss Hermitian matrix. When will you say that a matrix is Hermitian? First of all, the given matrix may be a complex matrix. If suppose I am considering a matrix D, as 1 plus I, 2, 2 minus I. This is the complex matrix. When will you say that a matrix is complex matrix? The entries or the elements of a matrix are complex numbers, then you can say that it is a complex matrix. So here you can observe that 1 plus I and 2 minus I means iota, are complex numbers. And 2 are real numbers, you know very well. So the complex conjugate of this matrix can be considered. The complex conjugate of the matrix, and if you transpose that one, then you can find this conjugate matrix, which means your D transpose is equal to, that means the complex conjugate of the transpose is denoted with theta, D power theta. Usually you can denote D power theta. So 1 plus I is replaced with 1 minus I. The complex conjugate of 1 plus I is 1 minus I. Simply replace plus with minus and minus with plus. Then you can get the complex conjugate of a complex number. So the complex conjugate of 1 plus I is 1 minus I. It is not a complex number, so it will be as it is, and it can be taken in a column. Okay. Now 2 is also there. 2 minus I. The complex conjugate is 2 plus I. Okay. So this is the transpose of a complex conjugate matrix. If D power theta is equal to D, Hermitian matrix, and if D power theta is equal to minus D, then it is, you can say that it is skew Hermitian matrix. So you can understand what I have explained about Hermitian and skew Hermitian matrix. I request all of you, please like, share, comment and subscribe my channel Balaya Math Lectures. Thank you.